Okay, well, let's just pick up from where we left off.
All right, cool. Sounds good to me.
On my notes, I've got where we went through question 34 on this test. So let's start from 35. I don't know if I told you or not. The GoToMeeting control panel that's on your desktop, you can make that be smaller by clicking on the orange arrow in the upper left hand. That's a toggle switch, which will make it get smaller or get bigger. It clears up.
No, yeah, it does it. It does it automatically for me.
Oh, it does. Okay, good. All right. Let's look at this problem right here. Now, whenever you see a solution, when you see a solution that looks like this, does that remind you of anything?
No.
What about the quadratic formula? Do you remember what it is?
Yeah. Like b or x equals plus or minus b to second, yeah.
Here's what it is. Okay, if we look at that, that is going to produce answers that look very much like that. Notice the similarities.
Yeah.
So if this is one solution, what's the other solution?
Look
at that.
Would it be
that plus?
E?
Look at that plus or minus. Yes.
Yeah, it'd be E.
Yes. In other words, 7 plus root 17 over 2. You know, if you're familiar with the quadratic formula and how to use it, then you know that it produces solutions that look a lot like that, what I have circled. In other words, it's going to be a plus or minus kind of solution. So if you recognize that, you instantly know the answer to this is E. However, let's assume we didn't know that. Well, if I was trying to solve this from scratch, how would I do it? If my equation is x squared minus 7x plus 8 equals 0, and the quadratic formula tells me that the solution to a quadratic equation can be always found using this. So let's figure out how to solve this quadratic. Without looking at the answers, what would the answer be here? What's minus b?
7.
Plus or minus, what's b squared?
17.
49. Minus 7 squared is 49.
Oh, yeah, okay.
Okay, minus 4. A is what?
7.
Actually,
No, sorry.
A is the coefficient of the squared term, so it's 1.
Okay, 1.
B is this term, and C is this term.
So 8.
Okay. Okay, so if we do that math, and it's all divided by 2a,
2.
which is 2.
1. Yeah, so 2.
Okay, so now we have 7 plus or minus the square root 49 minus 32 is 17 over 2. So those would be our two solutions. But a lot of people are used to looking at this. What does that mean? It means x is equal to 7 plus root 17 over 2, or x is equal to 7 minus root 17 over 2. And so when they gave you one solution here, we know the other solution has to be the plus end of it. If we're really familiar with the quadratic, we can get this problem in 10 seconds. If we have to actually use it to solve, then it's going to take a while longer. But you should be able to use the quadratic formula to solve a quadratic equation. Okay, let me just give you another one. Let's do a test on that. I'm going to make one up. Okay, so use the quadratic equation to solve this.
It's going to be negative 2.
Okay, remember here, let me write the quadratic. It's equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So let's just fill in.
So it'll just be 2.
Just plus 2, because it's minus a minus.
Yeah.
Okay.
2 plus or minus 2 squared minus 4 3 1
All over
2 times 2.
2 times
4.
3. In other words, this is a.
Oh yeah, again 2a, okay.
The coefficient of the x squared term is always a. B is always the coefficient of the x term, and c is always the constant. So it would be over 6. Yeah. Okay, so now if we try to simplify that, we get x equals 2 plus or minus, well, the square root of 4 minus 12 is negative 8 all over 6. So the fact that this is the square root of a negative 8 means that this particular problem that I just gave you only has imaginary solutions, because we're taking the square root of a negative number. So this would be 2 plus or minus the square root of 8i, because I is the square root of negative 1, all over 6. And then the square root of 8 is the same as the square root of 4 times the square root of 2. So the square root of 8 I can change into 2 square roots of 2. So this would be our answer to that particular quadratic.
Right.
Let's move on.
All right.
All right. If we have a square and its diagonal is 20, what's x? How do we solve that problem right there?
The square.
This is a right angle.
So we know that both legs have to be the same since it's a square.
Right. That's why I've labeled them x and x. Okay. We still have to solve for x though. What kind of an equation can I write now based on this?
X plus X equal, or X squared plus X squared equals 20 squared.
Good. Now let's solve that equation.
So it'd be X power 4.
Okay, when you're adding exponentials, you just add them. This is like I have one apple and I'm adding another apple, so I have two apples.
Oh, 2x to the power 2?
Right, it's not the same as x squared times x squared. X squared times x squared would be equal to x to the 4th. But notice this is multiplication here, and what we're doing in this problem is addition. So if I have one apple and I add another apple, I get 2 apples. So we have 2x squared equals 400. Okay. Now what?
We square root both sides.
Well, first we want to isolate the x squared before we take the square root of both sides.
So divide by 2.
There you go. So now we have x squared equals 200.
200.
Okay, so now you can take the square root of both sides, and x is equal to what?
X is equal to 14.14213.
Notice that that's not an answer on there. In other words, that calculator is going to help you sometimes, but it's really going to hurt you sometimes also. I guess you could take that answer and figure out which of these is equal to that number. It's not a bad way to go. Let's examine that approach. In other words, they allow you to use a calculator here, so we know x is the square root of 200, first of all, right?
Yeah.
Okay, so the question is, what is the square root of 200? And your calculator told you what?
14.1421356.
Which of those answers is that number?
G.
Has to be, right? Certainly it's an F.
Yeah.
It's not H, not J. And this number here is bigger than 14. So the only thing left is G. So the calculator helped you a little bit. In other words, you could actually use the calculator to get the right answer. But let's look at this a little bit more, because you really need to know how to simplify problems like this. How do I simplify the square root of 200? Well, let me look for factors of 200 where one of the factors is a perfect square. So how about that's the square root of 100 times the square root of 2? In other words, the square root of a times b is equal to the square root of a times the square root of b. So I can say the square root of 200 is equal to the square root of 100 times the square root of 2. What's the square root of 100?
10.
There's my answer. Notice that,
okay.
Notice that by doing it without a calculator, I actually get the answer that's shown. They really kind of want you to do this without a calculator. And that's why their answers are exact answers. 10 square root of 2 is an exact answer as opposed to 14.14, which is actually an approximate answer that's been rounded off. All right, let's go to the next page, 256. Okay, what is 3a minus 4 times a plus 2?
it would be 3a squared minus 4a plus 2. Oh, wait, no.
Make sure
Plus
you
8.
make sure that you multiply. In other words, they tell you FOIL. I'm sure you've heard of FOIL. And FOIL means first, outside, inside, last. So the first term is going to be 3a squared. The outside terms are going to be plus 6a, right? 3a times 2.
Yeah.
Inside terms are going to be minus 4a. And the last two terms are going to be minus 8. And now I can combine these two, because they're the same things, they're a's, to come up with 3a squared plus 2a minus 8. Here's your answer.
Yeah. I forgot about the
C.
3a times 2.
Okay, when you're multiplying polynomials times each other, you don't really need FOIL. Let's throw FOIL out the window. What do we need to know? We need to know that we need to take every term and multiply it by every other term. So I need to multiply 3a times a. I need to multiply 3a times 2. I need to multiply minus 4 times a and minus 4 times 2. So this method covers a problem like, what if I was going to multiply this by this? In other words, here I have a binomial times a trinomial. Well, if I use FOIL, it doesn't do me any good, right? FOIL doesn't cover this. But if I use my definition, where we're going to take every term and multiply it by every other term, then I end up with 3a times that, 3a times that, 3a times that, and then minus 4 times that, minus 4 times that, minus 4 times that. And then I end up with something that I can simplify. So is all you really need to know when you're multiplying a polynomial by a polynomial is make sure you multiply every term by every term.
Yeah.
That's what FOIL actually does. You'll notice it does first, then it does outside, then it does inside, and then it does last. All right. $38. The midpoint is at 4, 8. I'm going to make 4, 8 right there. The ends of this line are 4, 2. So 4, 2 must be about there, right? And that's point A. And point C are 4, S. Well, 4, S is way up here because 4, 8 is the midpoint. And the coordinates of C are 4, S. So we have a straight line here where that's the midpoint.
Right. So this means the S would have to be 14 because A is 6 points below the midpoint.
Exactly.
So it means it would have to be 6 points above, which means it would be 4, 14, which would be K.
Exactly. Very good. Let's go on. When I see that you understand something, I won't waste too much time talking about it. It's clear you know that one.
All right.
And go ahead and read these to yourself, because when you take this test, you're going to be reading them to yourself. You're not going to be reading them out loud or anything.
Okay.
Okay, whenever you're solving a word problem, and this is a word problem, the most important thing to do is always start off defining your variable and what it means. Just remember that. Whenever you run into a word problem, start off by defining your variable and say what it means. Well, they've done that for you in the last sentence already. They've said S represents the first number. So they want to know what represents the sum of the three numbers in terms of S. So if S represents the first number, what's the second number?
Wait. 5 more.
Okay, the second number is 3 less than 4 times the first number. How would I write that? What is 3 less than 4 times the first number?
4, wait.
Yes.
3 minus 4.
No, you had it right the first time. 4s minus 3.
3.
Notice that that fits the description exactly. That is 3 less than 4 times the first number, right? Notice that it's not this. It is not 3 minus 4s. In other words, they always try to confuse you with word problems by putting what is being subtracted first. Notice that they said the second number is 3 less. They will always do that. In other words, whenever 3 is going to be subtracted, they're going to say it's 3 less than that. So you have to be careful with that. You have to be careful not to put it in the wrong order. It's not 3 minus 4s, it's 4s minus 3. That is 3 less than 4 times the first number. Okay, what's the third number?
Third number would be, 2s plus 5.
Good. What's the
So if you add those together,
what do we get?
We get 6s plus 2.
Okay, how many total s's do we have? Oh, what about this one up here?
6.
Well, what about this one? We got 1.
Oh, the one more s.
Yeah, so we got 7s.
7 plus 2, so E.
Right. Okay, a little geometry here. Now, in geometry, when you're looking at geometry problems and they have triangles in them, what's the most important thing in geometry to remember about a triangle? What do I know about these three angles?
That they all add up to 160, 80 degrees?
180. That's the most important thing to remember. Yeah. Okay? Another thing very important in geometry, what do these angles add up to? A and B.
Which ones? Wait. A and B?
Uh-huh.
Wait, one.
They also add up to 180. In other words, no matter if I have a straight line and I intersect it with another line, these two angles are always supplementary, which means they add to 180.
Right. Oh, okay.
Okay? So if I look at this problem, I have a couple angles over here, and then I have this triangle here, and then I have this little triangle here, plus a couple angles right there. So the goal on this problem is going to be to solve everything we know. So what is this angle right here?
50.
Okay. So if this is 50 and this is 80, what is this angle C?
C would have to be 20.
Well, that's 50. That's 80. This angle here, this plus this have to be 180, so this would have to be 50 also.
50.
Okay.
Yeah.
This is 110, so what's this angle here?
110.
No, remember 110 plus this angle have to be 180. So this angle right here, that would have to be 70. So far, the only thing we've used is the idea that all three angles have to add to 180 and supplementary angles have to add to 180. Okay? So now
angle E would have to be 60.
Right. And that's what they're looking for. That's their answer. Notice that that's angle DEC. It's that angle right there.
Yeah.
So the idea here is that whenever you have multiple triangles, notice that we have two triangles, always try to solve these by solving for whatever you can solve for. Okay.
Yeah.
Well, the first thing I can solve for is this angle right here. That's 50. That means the next thing I can solve for is this. Well, I can also solve for this. Once I have this and this, I can now solve for that. So that's the way all of these geometry problems kind of work, is you just start labeling stuff that you can figure out. Don't immediately try to solve for this angle. You can't do it. But if you solve for this angle, now you can solve for this angle, and then you solve for this angle, and once you get this angle and this angle, you know that angle.
Right.
So they're all kind of piecemeal. 257 we need next. They're not going to give you a problem that is a one-step problem. All the problems they give you are going to be multiple steps.
Right.
In other words, they're not going to give you a problem like this. This is 70, this is 60, what's this? That's too easy.
Oh, that's 50.
Right. But you won't see a problem that easy on there. It's always going to be something that requires a few different steps. Okay, 41.
Yeah. So you would do.
What's the ratio that they're looking for?
170 over 200?
No. They want to know what percentage of the original price did Jack lose. So how many dollars did he lose?
30.
So it's 30 divided by what?
Well, 200.
Right, because what percent of the original price, not the sales price, but the original price. So you're right, it's 30 over 200. What percent is that?
15%, which would be C.
Okay, good. Okay, here's another one, another trig question. Remember, there's 4 trig questions on the test. Exactly. So we start off with the cosine of x is equal to minus 1/2.
Right. So which of the following is the 7? So we would have to do that out, right? The cosine thing?
Well, let's look at our unit circle. If you remember the unit circle, there's 4 quadrants. And if you remember, all students take calculus. Did you learn that?
No.
That tells you which trig functions are positive in which of these quadrants. Without giving you a trig lesson, I'm trying to figure out what the easiest way for you to answer this question would be if you used your calculator. Try finding the inverse cosine of negative 1/2. In other words, let's not go to the unit circle because that's a lot of information. How would I solve this problem right here? Cosine of x is equal to negative 1/2. So what is x equal to?
Negative 1/2?
It's
Or
equal to the inverse
inverse
cosine of negative 1/2. And the
Right.
way that works, just in case you're wondering, is I'm going to take the inverse cosine of both sides. It's an equation. I can do anything I want to an equation as long as I do it to the same side. So I'm going to take the inverse cosine of the left side. I'm going to take the inverse cosine of the right side. Well, when I do this, I'm left with x. When I do the right side, I got the inverse cosine of negative 1/2. So try to get that in your calculator. Only make sure your calculator is in radians, because these answers are all in radians. Notice they're not in degrees. Do you know how to put your calculator in radian mode as opposed to degree mode?
Yeah.
Okay, put it in radian mode, and then look up the inverse cosine of negative 1/2. What does it tell you?
I got 2.094.
Okay. Now, they're not going to give it to you in radians, but we might be able to convert that to radians. Which one of these, let me say one other thing. Your calculator is only going to give you one answer because that's the way it's set up. It's going to give you the primary solution. This problem is the entire unit circle, and there's always 2 quadrants where the cosine is negative. All trig functions are positive in the first quadrant. Sine is positive only in the second quadrant. Tangent is positive in the third, and cosine is positive in the fourth. What that means is that cosine is negative in the second and negative in the third. So there's actually 2 answers to this question. There's the second quadrant answer and the third quadrant. Well, let's see if we can figure out what the second quadrant answer is, because that's what each of these answers is that's the second quadrant and that's the third quadrant. Well, your calculator only goes through the second quadrant. So this number 2.094, which of these initial numbers does that correspond to? If you look in your calculator and you do, pi is about 3.14, so clearly pi over 6 isn't it. Pi over 3 is close to 1. That's not it. Pi over 2 is half of that number, so that's not it. 2 pi over 3 looks like it could be it. Do 2 pi over 3 in your calculator and see if you don't get real close to 2.094.
It's the same thing.
Right. So we know our answer is which possibilities could be our answer?
J and K.
Exactly. So just by using your calculator, we've narrowed it down to two choices. Now, if you really know your trig, you know that the second choice is in the third quadrant. Which of these numbers is in the third quadrant? Remember, if I were to label my unit circle, looks like this in radians. This is pi over 2. This is pi. This is 3 pi over 2. And this is back to 2 pi. Okay? So if my first answer was 2 pi over 3, that's second quadrant. It's between pi over 2 and pi. So I'm looking for another answer that's in this third quadrant. It has to be between pi and 3 pi over 2. So is that J or is that K?
J.
Exactly. In other words, we don't even have to know that's the answer. We can look, we know our answer is either J or K, and we're looking for the one where the second number is a third quadrant number. 4 pi over 3 is in the third quadrant. 5 pi over 3 is in the fourth quadrant. So this can't be the answer here. Now, this is probably the toughest question you will encounter on the ACT. This is a tough one. You have to know your trig really well to be able to do this one. Although even with just a calculator and kind of knowing your unit circle, just with a calculator we can narrow it down to either J or K. Knowing a little bit about the unit circle allows us to narrow it down to J. Sometimes on the ACT, if you can take 5 possible answers and get rid of 3 of them and narrow it down to these 2, now you can guess and you're 50-50 to get it right. So it's worthwhile figuring out what one of those is. Okay.
Yeah.
Why was I using the unit circle? Because it said x was between 0 and 2 pi. So I had to cover all 4 quadrants. Okay, this question is a little similar to the first one we looked at tonight. It's a quadratic. Where, again, they give us one solution. X equals 1. If I were to try to factor this, in other words, if I were to try to solve this without the quadratic, I would do it like this.
It would be 5x. And the other side would also be 5x.
No. If the other side was 5x, this would have to be 25x squared. So the other side has to be just
5x and then just x.
Right. And that gives you the proper first term of 5x squared. Now, this term right here, rather than finishing our factoring, what does this have to be? They've told us that x equals 1 is a solution. So this factor, it must be what? This one right here. If x equals 1 is a solution, then x minus 1 must be one of the factors.
Right. And the other one would have to be a 7.
And the sign on it?
Plus 7.
Okay. Now, had we finished factoring, this is what we would have gotten. But when they told us that x equals 1 as a solution, notice that if we would have factored this on our own, we would have gotten this. Once we get this step,
right,
we have two things being multiplied together equals 0. That means we set each one equals 0. So I'll set 5x plus 7 equal to 0, and I'll set x minus 1 equal to 0. Well, when I solve this one, I get x equals 1. I'm sorry, x minus 1 equals 0. And then when I solve this, I get x equals 1. Well, they gave us the x equals 1 to begin with. So that told us that one of these factors was x minus 1. In other words, this information, x equal 1, tells us this factor. Once we have this factor, coming up with the other one's pretty easy, right? I mean, we don't even have to do any trial and error. If one of the factors is x minus 1, the other one has to be 5x plus 7. So if 5x plus 7 is equal to 0, what is x equal to?
1.
There's two answers for x. One answer comes from this factor. The other answer comes from this factor. Solve that.
It has to be 0.
No, solve this equation. 5x plus 7 equals 0.
Let me see. Be 1.4.
Don't do it on your calculator, because notice that the answers aren't the kind of answers you get from the calculator. Let's solve this manually. So what's the next step? You obviously you obviously were able to solve it because you came up with the right answer. But let's just go through solving this equation. What's the first step of solving that equation?
Put 7 on the other side so you can get 5x alone.
Now what?
Divide by 5.
There's our answer. Notice that I didn't use a calculator and I got straight to it. You got the right answer, negative 1.4, but that isn't on multiple choice. They put the answers you would get if you were going to do it manually.
Right.
In all honesty, that calculator is going to be very limited benefit to you. They don't really set this test up to give people with calculators an advantage. They don't want this to be a test as to how well you can use your calculator. They want this to be a test on how well you understand how to do these problems. So it's rare that you should go to your calculator first. Only go to your calculator to verify arithmetic or whatever. But notice that the answers are usually answers that you get by manually doing it, not by doing it in the calculator.
All right, that makes sense.
Okay. Let's talk about parallel lines and transversals before we look at this next problem, because ACT has a lot of questions on it that have to do with parallel lines and a transversal. If you traverse two parallel lines with a transversal, you create two angles. You actually create 8 angles. This one, this one, this one, this one, this one, and this one. But there's only 2 unique angles created. A big one and a little one. And they always add to 180. And every one of these other angles is either A or B. So what is this angle here?
B.
What's this angle?
A.
What's this angle?
B.
No, it's the big one.
Oh, A. A.
This is the little one. This is the little one. This is the big one. So when we cut this 2 parallel lines with a transversal, we created 8 angles, but only 2 unique angles, A and B. And A and B add to 180. So this is all you need to know about parallel lines and transversals. With this information, you can answer every single question they're going to ask you about parallel lines and transversals. They'll try to confuse you a little bit. In this problem, they actually give you 2 sets of parallel lines and 2 transversals. So it's not quite the simple case that I've laid out here. But we can still do it. Let me draw it. It's a parallelogram. I'm going to make these dotted lines just to make it a little clearer what our solution is. It's T, that's P, that's Q, that's S, that's R. And the information is that PST is 65 degrees. PST is 65. And
Right.
QRT is 35. QRT, so this one's 35. And they want to know what PTQ is. This one right here. That angle. So, like most ACT problems, this is a multiple step question. We have to start labeling some of the angles that we can't immediately know what angle T is.
Right.
But we can
So
tell me some of the other angles that I do know here.
if TRQ is 35 degrees, which that would mean that SPT is also 35 degrees.
Okay. Good.
Or the other side. The other side. Right?
And SPT. Oh, you're absolutely right. I labeled the wrong one. This one is 35. Okay.
Which means that 35 plus 65 is 100, which means that angle PTS has to be 100.
Not 100. They have to add to 180.
Oh, 80. Yeah.
Okay. Now that you know that angle, what is angle T or PTQ?
PTQ would have to be 100.
Right, because it has to be supplementary with 80. So that's
Right.
equal to 100.
To equal the 180.
Right. Okay, so the answer is J. Again, it's a problem where if you don't know how to start a problem, just start filling in information that you do know. It's like, I know that's 35 because that's parallel to that, and that's 35, so that has to be 35. Once I know that's 35, now I know these 3 angles have to add to 180. So they all have a similar thing. We need 258 next. I can't overemphasize this principle that if you don't know how to begin on a problem, begin somewhere. Just begin and start writing down information that you know. All right. It's 8 o'clock. You want to do one more? This is fairly tough.
I actually have to go.
You have to go? Okay, we started a little late, so I thought you might want to go a little bit over. But that's okay. I'll put in the notes that we ended on 44, and we can pick up from this one next time.
All right, cool. Thank you very much.
Okay, Joel. Have a good one, and I'll talk to you later. Incidentally, I got the check from your mom, which covered our last 2 sessions. So.
All right, cool.
Okay?
All right, thank you very much.
All right, Joel. Have a good night.
You too.